My name is Gabriel Axel Montes, and yes, I've come all the way from Australia. I have a talk that has been adapted from conferences in philosophy of psychology type of work. This is probably the most abstract thing you'll hear all day today, maybe even in the entire conference. So the title is the Causal Biomimesis, Self-Replication as Evolutionary Consequence. So I'm basically interested in how we get from upper left to upper right, from kind of more primitive tool-using hominins into humans that can produce something as complex as humanoid robots and AI. And I think it has something to do with what's happening, the transition from lower right to lower left to lower right. So essentially, quadrupedal power grip, early apes and monkeys, to the transition to bipedal locomotion and precision grip. So basically, it essentially begins with prehension, and we have the transition from the power grip to a precision grip. And basically, when quadrupeds descend from their arboreal habitats, there's a strong selection pressure for them to develop prehensile ability and to become more and more refined at this. So there's a strong hand and brain coevolution and a dexterity-driven brain development. So what happens when they're using tools, homins are using tools, is there's a lot of creative problem solving. So there's a sense of a gap in terms of what wants to be achieved, and there's creativity employed in solving some kind of a problem. And there's a teleological reasoning. So how do we get from A to B? So if I want to cut this branch, how do I get to that point? And basically, you could say that the way that we are engaging our mind has shifted a lot from the geospatial awareness, which maybe relates to this olfactory system. Very interesting talk, by the way. I hadn't considered that. And it gets transferred to the conceptual. So the entorhinal cortex in the brain has actually been shown to be able to be co-opted for representing conceptual knowledge. So before, when we're quadrupedal, we're more arboreal and we're encoding geospatial information. And then as we become bipedal and we free up the hands and there's dexterity and prehensivity, there's a bit more of an emphasis on conceptual information and tool making. So when this is happening, there's objective thought being fostered and promoted because there's a utilitarian nature in the act involved in making and using a tool. What's good for me? What's good for my conspecifics or the other agents in my system or my social group? So a sense of self and other consciousness is fostered, and there's a minimization of entropy or free energy, if you're familiar with free energy principle. So basically, the agent is a homeostatic entity in an entropic world, and by creating tools, he's fostering a sense of reflection on who he is or she is and his or her conspecifics. And this, in turn, leads to minimization of entropy and greater self-understanding. So tools become externalized artifacts in the agent's extended mind. So every time a tool is produced, it becomes an externalized artifact that basically represents the cognitive process that was involved in creating the tool. And from prehension, you have the facilitation of ostension. Ostension is essentially virtual prehension. So it's, imagine instead of grabbing a fruit, you can't quite grab it, so you develop a pointing mechanism, and that's kind of where prehension turns into symbolic representation. So from this, we get kind of a very prototypical pre-scientific method, if you will. So the ecosystem is becoming a repository of potential tools with this kind of instrumental cognition at play. And then the artifacts that are produced result in all these aggregates that then can be compiled together to form new tools. So you have a social ecosystem of extended minds from one agent and other agents and the group as a whole. And it self-organizes through continuous production of tools, engagement with tools, and stigmergy. So basically the traces left from the actions that produce the tools basically invite and draw in other agents to engage with those artifacts as well. And essentially what happens is tool making and tool use is a kind of prototypical hypothesis testing. So you have observations about your environment, and you observe that you need to, there's a tree branch that you need to cut for whatever reason, and there's a question is how can I potentially improve my efficiency of doing this? And you might develop a hypothesis. I think that adding a lever to this tactical stone will increase the power of my percussive strike. And then you go and you test, you build your axe. And you test the data and see how it works. You analyze and see if it produces a result that motivates you to do it again, or if it has the intention, matches the intention that you had for making the tool in the first place. And you might repeat it again, replicating it, or you might have a kind of peer review method, which is your other social conspecifics start to mimic your action and maybe test it, and then you see if it's good for the tribe or the group as a whole. So this feedback between the instrumental process and the sense of objectivity you're getting by creating tools and reflecting on yourself as an agent in a world with goals tends to continually reify in this kind of soup, this loop of self and other consciousness, and what's good for me and what's good for my group. And this creates a sort of snowball effect. So this is a bit of a leap here, but we can see how as you continue creating tools and externalizing artifacts of cognition, you get more and more complex tools that aggregate in the environment, forming this vast archaeology of extended mind. So you think Andy Clark here, the philosopher of mind. And you get more and more complex artifacts as your sense of self is able to offload cognition into artifacts and freeing up your mind for other tasks. Tools become more and more and more complex. I'm breezing through this, obviously. So then, basically, these artifactual arrangements support increasing self-reflectivity and knowledge, allowing for more complex tools to continually be made. And eventually, you get to the enterprise of modern science and biomimetics, which is a long leap of natural progression from this pre- or proto-scientific methodology as a result of instrumental cognition. So what I'm calling gross biomimetics is kind of the obvious, what we're all doing here. We're consciously trying to solve engineering problems through bio-inspired design. Now, what I'm calling subtle biomimetics is basically what's happening naturally as we try to understand a natural system. So let's say we're trying to understand the brain, right? And here is a model from a lab I did some work at, the Geschwin lab at UCLA, where they work on transcription factors like FOXP2, the language gene, maybe you've heard of that. So essentially, if you were gathering data about the brain, you have curiosity. How does this work? Let's gather some data. And then we need increased computational power to be able to process that data, to make sense of it. And then this leads to an increased understanding of the natural system in question, the brain in this case. And then we have further observed gaps in understanding. We want to solve more questions, and this leads to more curiosity. What happens is, though, as there's more of a need to process the increased complexity of data, especially as a result of more complex tools that can gather more and more complex data, the actual computational power of the machines or the computers that are processing this information needs to continue increasing to keep up with this. Maybe to the point where we have to develop quantum computers to understand the complex data that's arising from the natural system, like the brain. So we have data gluttony. And what happens is, after a while, what I see as a sort of a natural logical consequence of this process is that we continue building and building and building until we reach a point where, like almost an event horizon, where it seems like, well, we're trying to understand the brain, but at this point, we've basically replicated the brain as far as we can tell. So you end up with a sort of de facto replication unintentionally. That's why I'm calling that subtle biomimesis, because it's happening subtly and unintentionally. There are people trying to actually replicate the brain, but that's not necessarily what's happening as a result of this curiosity, data collection, computational power cycle I'm describing. So you're getting knowledge of the natural system, you're gaining knowledge of yourself as an agent in the process of doing this, and the knowledge that you're gaining is itself a reward. And I don't think we're cognizant of this process, the subconscious process of this. So along the way, what are being constructed are artifact hold-ons. So every time that you have a portion of your cognition being offloaded to the environment, that could be something you term a hold-on. So it's kind of a complete sort of cognitive artifact that stands alone. And they more or less resemble comprehensive cognitive functions, and this becomes more obvious when you say, we used to drive and now we're completely outsourcing and offloading driving ability, or even something like virtual reality, which we're actually actively trying to mimic what it's like to be present in an environment. So you're literally trying to find, how do we hack or meet the brain's requirements for plausibility and presence and being localized somewhere. So this co-enactment of self-awareness, self-consciousness, and the artifactualization means that there is a constant co-modeling of self and artifact along the way at every stage, whether it's something as simple as I want to offload the percussive power into an axe, whether I want to offload mathematical computation into a calculator, or driving into an autonomous vehicle. So this entire time, you have a covert projection of cognitive functions in your system onto something external as a tool. And if you keep going, there's a sense of an agent as a sense of self. And that means that there's going to be a projection of selfhood at some point. So I mean, we're talking about a species that sees the faces of human on the moon, or sees a Virgin Mary on a piece of toast, and we're actively creating robots that are in our image. So there's kind of this process of agency transference. That's what I'm calling agency transference, where it's basically you're actively seeking to see a sense of self in the product you're creating, whether it's in small holes, like pieces of cognition, or eventually an entire agent. So our biology, and therefore our cognition, is autopoietically organized. So there's a self-organization going on, and us co-enacting in concert with our artifacts, that means our extended mind will be autopoietically organized. And because of the self-consciousness aspect that's woven into instrumental cognition, that agency transference will be taking place surreptitiously or unconsciously. So once there's sufficient self-resemblance, then it's kind of more obvious that, oh, there's an agent that we're creating here. And agency transference is more obvious. So once there's autonomous agency in AI, there will be agency countertransference, which means the artificial agent will also transference or transfer or project agency back onto us. So there's going to be a co-enaction going on, not just us dumping or offloading our cognition into this static tool, but it's going to be interacting with us on the agent level. So then that's where things start to get interesting. I don't think that we're cognizant that this is happening by virtue of its own mechanism. That's part of what I'm arguing, that it's happening on its own. And the next slide will explain more. This was supposed to be an animated piece, but if you remember the movie Fight Club, where Brad Pitt or Tyler Durden, at some point there's a real change in the theater, and he points to something that he calls cigarette burns or marks on the upper corner. So I kind of thought of that to kind of refer to the transfer of agency, and even previously artifact holons or cognitive functions, into the environment.
3 minutes.
Yep, got it. So causal biomimesis is basically what I'm saying is happening ab initio. So it's essentially the self-replication is latent in instrumental cognition in that process in and of itself, at least in humans on a cognitive level, since we have begun using tools and since early prehension as early hominins. And probably in autopoietic systems too, as basically cells and such are agents that are trying to minimize free energy and working and modeling the world. Skip a few of those points. So part of what's happening here is that we're moving into a post-biological or post-sexual reproduction. So you have eventually cultural memes, digital memes, and human-computer information, and then this synthetic biohybrid reproduction is taking place because your objectivity and sense of self and creating tools is always offloading, and eventually you have this agency production. So this, what I'm calling the anthropogenic biomimetic cycle, is not complete until the replicants can replicate themselves. So again, it begins from instrumental cognition and objective reasoning and prehensile hominin to the event in which the next generation can fully self-replicate on its own. And this is a model from my paper. I won't go into it, but the paper is available. And there's existential and ethical considerations that result from this. Basically, we are actively projecting into AI what we believe ourselves to be. So the people that are designing this, whoever that may be, us included, are basically taking what we think ourselves to be and using some sort of Turing test to assess if the AI is sufficiently human. So part of the implication here is that I believe we need to consider the quote-unquote farther reaches of human nature, anything as simple as empathy, compassion, which are already being investigated, but even beyond that to artistic creativity and non-ordinary consciousness, capabilities of humans that we're not fully yet aware of and don't fully value at present, even with or without AI. So one question is, will we replicate awareness or consciousness, or just agency? That's a bit of an open question. I remain agnostic. I think agency most likely. And it may not happen that it's fully synthetic. It might be a biohybridity along the way. So I think humans are playing an active role. There is a relatively limited time window because there are going to be generations born with these humanoid agents that are going to be influencing what those humans think agents and humans actually are. So we're going to be entering into more equal relationship than we have now. So it's even more important, I think. So I think it's important to unearth and value undiscovered abilities and incorporate this into the design of AI. So that's it.